Welcome to my presentation. This presentation is part of the playlist The Chain Rule. In this presentation, we will be solving problems using the chain rule. Let's look at some example problems. Let us say we have a function y is equal to the square root of 5x minus 2. We want to find the derivative of these complex functions. Whenever we have complex functions, we want to be able to split it up into two parts, identify the inner function and then identify the outside function and then be able to apply the chain rule from that point on. So let us identify the inside function. Let's call the inside function as u, and then we'll call it as equal to 5x minus 2. Let u be equal to 5x minus 2, and therefore automatically the outside function y will be equal to the square root of u. So um, yeah, square root of u. Now we can express the radical terms in terms of exponents as u to the power of half. So we want to express it as u to the power of half because we can apply the power rule from that point on. So now we have two functions. We have the given problem. We have divided it into two parts, the inside function and the outside function. We're going to differentiate the inside function separately and the outside function separately. The inside function is u, which is equal to 5x minus 2. U is a function of x, and the outside function y is a function of u. So we can differentiate u with respect to x, and when we do that, du by dx is equal to d by dx of 5x minus 2. D by dx of 5x is 5. D by dx of 2 is 0. And when we simplify, that equals to 5. On this side, y is a function of u. We're going to differentiate it with respect to u. So dy by du is equal to d by du of u to the power of half. So we can use the power rule. And when we use the power rule, we can write it as 1/2 times u to the power of half minus 1. Half minus 1 is 1/2. So when we simplify it, it's going to be 1/2 times u to the power of minus 1/2. We have the value of dy by du, and we also have the value of du by dx. So now we are ready to use the chain rule. The chain rule is stating dy by dx is equal to dy by du times du by dx. So we have the value of dy by du as 1/2 u to the power of minus 1/2, and that's what we have here. And then we know the value of du by dx as 5, and that's what we wrote here. So when we combine these, 1/2 times 5 is 5 over 2 u to the power of minus 1/2. But we cannot have u as part of the answer. So therefore, we're going to substitute the value of u. We have u, we started to say let u be equal to 5x minus 2. Wherever we see u, we're going to substitute the value 5x minus 2. We can write it as 5 over 2 times 5x minus 2, the whole thing raised to the power of minus 1/2. So we can express an exponent as a positive exponent by bringing it to the denominator. 5x minus 2 to the power of minus 1/2. When we bring it to the denominator, we can write it as 5x minus 2 to the power of plus 1/2. So therefore, we can write it as 5 over 2 times 5x minus 2 to the power of 1/2. We can express an exponent as a radical term, and that's what we have expressed it here. 5 over 2 times the square root of 5x minus 2. Expressing it in these two different ways is correct. So either we can leave it as an exponent, or we can write it out as a radical term. Both ways of expressing the answer is correct. So this is the way we want to use the chain rule to solve complex problems. Let's look at another example. Let's say this time we have y is equal to the square root of 1 minus x squared. We want to find the derivative of this complex function. Again, we want to identify the inside function and therefore also identify the outside function. The inside function here, let us call it as u. Let u be equal to 1 minus x squared. Therefore, y we can write as square root of u. We can express the radical term as an exponent by expressing it as shown here. Square root of u we can write as u to the power of 1/2. We want to do that because we can then use the power rule to simplify it. We have two functions now. We have a function u which is a we have u as a function which is 1 minus x squared, and we have y as an outside function which is u to the power of 1/2. U is a function of x and y is a function of u. We're going to differentiate this u function with respect to x, and when we do that, du by dx is equal to d by dx of 1 minus x squared. So d by dx of 1 is 0. D by dx of x squared is 2x to the power of 2 minus 1. We are using the power rule here. So when we simplify it some more, we have negative 2x. So now we have, on this side, we have y as a function of u. We're going to differentiate it with respect to u. dy by du is equal to d by du of u to the power of 1/2. So we can use the power rule, and when we use that, it simplifies to 1/2 times u to the power of 1/2 minus 1. And we can simplify it some more as 1/2 times u to the power of minus 1/2. 1/2 minus 1 is minus 1/2. So therefore now we can use the chain rule. We have the value of dy by du, and we also have the value of du by dx. The chain rule is stating dy by dx is equal to dy by du times du by dx. dy by du is 1/2 u to the power of minus 1/2. That's what we have here. And then du by dx is minus 2x, and that's what we have here. So when we simplify it, 1/2 times minus 2x will be equal to minus x times u to the power of minus 1/2. But we have u as equal to 1 minus x squared. We started by letting u be equal to 1 minus x squared. Therefore, wherever we see u, we're going to substitute the value of 1 minus x squared like that. So therefore, we can write it as minus x times 1 minus x squared, the whole thing raised to the power of minus 1 over 2. We can also express a negative exponent as a positive exponent by bringing it to the denominator. Therefore, we can write this one as minus x divided by 1 minus x squared, the whole thing raised to the power of plus 1/2. Okay. We can also express the exponential term as a radical term by writing it as shown here, minus x divided by square root of 1 minus x squared. So this is our answer. This is the way we should be able to solve complex problems using the chain rule. Let's look at another example. Let's say this time we have a function y is equal to the square root of t plus 1. We want to find the derivative of this complex function. We want to identify the inside function and we want to identify the outside function, and then differentiate them separately, use the chain rule, and then apply and then simplify the problem, and then arrive at our solution. Let us see how we can do that. Let's call the inside function as u. Therefore, u will be equal to t plus 1. And then the outside function automatically we can write as the square root of u. So we can express the radical term as an exponent as shown here. We can write square root of u as equal to u to the power of 1/2. We have two functions now. U is a function of t and y is a function of u. We can differentiate the u function with respect to t. We can differentiate the y function with respect to u. Du by dt is equal to d by dt of t plus 1. D by dt of t is 1. D by dt of 1 is 0. And therefore, it simplifies to 1. On this side, y is equal to u to the power of 1/2. When we differentiate it with respect to t, dy by du is equal to d by du of u to the power of 1/2. We can use the power rule, and when we use the power rule, and it simplifies to 1/2 times u to the power of 1/2 minus 1. 1/2 minus 1 is minus 1/2. So it simplifies to 1/2 times u to the power of minus 1/2. Now we are ready to use the chain rule. We know the value of dy by du. We know the value of du by dt. So the chain rule is stating dy by dt is equal to dy by du times du by dt. So dy by dt, that will be equal to dy by du is 1/2 times u to the power of minus 1/2. That's what we wrote here. And then du by dt is 1, and that's what we have here. Now we can simplify it some more. 1/2 times 1 is 1/2, u to the power of minus 1/2. But u is equal to t plus 1. That's what we started to say. Therefore, wherever we see t, wherever we see u, we're going to substitute t plus 1. So 1/2 t plus 1 to the power of minus 1/2. Or we can write this one as 1 over 2 times t plus 1 to the power of 1/2. We can also express the exponent as a radical term by writing it as shown here. 1 divided by 2 square root of t plus 1. And this is our answer. This is the way we're going to solve complex functions using the chain rule. In my next video presentation, we will be solving more problems using the chain rule.